This video is going to talk about how to find the surface area of a rectangular prism. I'm going to show you two different ways in which you can do this. I'm only going to show you one example of each way. At the end of the video, it's going to be your job to tell me which of these ways you think might work better for you. And that is going to be the question at the end of the video, so pay attention so that you're ready to answer that particular question. This is a rectangular prism. We've worked with these before, we found the volume of these. This is a rectangular prism that has been taken apart and unfolded. Much like you unfold a cardboard box, we have unfolded this rectangular prism to show the net. So what we're going to do is, for this first example, we are going to use the formula for the surface area of a rectangular prism. And the formula for the surface area of a rectangular prism is 2 times length times width plus 2 times length times height plus 2 times width times height. And that formula is put into place because if you think about a rectangular prism, there are actually only 3 sides of different lengths, and then those sides are doubled. So we have the side and the other side, and both of these sides are the same dimension. They both have the same area. We have the top and the bottom, and the top and the bottom both have the same area. And then we have the front and the back, and the front and the back both have the same area. What we're trying to do with surface area is we're trying to cover this in wrapping paper. We are trying to find the area of all of the sides so that we know how much wrapping paper we would need to cover this entire thing. When you wrap a present, typically you use more wrapping paper so you can tape it, but we're just going to ignore that. So let's go ahead and let's try using the formula for this example, and let's see where we get. So I know that surface area is 2 length plus width plus 2 length plus height plus 2 length width, 2 length height, and 2 W height. So let's go ahead and let's plug in the numbers. My length is 5. So every time I see length, I'm going to put a 5. My width is 4. So every time I see a W, I'm going to put a 4. My height is 6. So same thing with that. And then we're going to write the rest of the formula. And remember that there's a 2 in each of that. So these individual parts are being multiplied, and then after they're all multiplied, they're going to be added. So I'm going to save a little bit of space here. We know that 2 times 5 is 10, times 4 is 40. 2 times 5 is 10, times 6 is 60. 2 times 4 is 8, times 6 is 48. Now, I doubled these because of the front and back. That's what the extra 2 is thrown in there for. And now what I have to do is I have to add all this up. So now I have 40, 60, and 48. And I'm going to add 8 plus 0 plus 0, 6 plus 4 is 10, plus another 4 is 14. So my surface area is going to be 148 miles squared. And it's going to be miles squared because I'm really trying to find the area of this entire net, but it's been folded up. Kind of like when you find the perimeter, it's not squared because it's just one straight line that's been broken up to go around a shape. Surface area is the same thing. It's really just 2 dimensions, but it's been folded up into a 3-dimensional space. So that's the first way, and that's by following the formula. The formula might not work for everyone. You might want something a little bit more visual. So with this, we're going to utilize the net a lot more. You can see that I have orange lines here, and the orange lines are straight. You can see that I have pink lines that are kind of jagged or fuzzy because I noticed you really couldn't tell the difference between the orange and the pink. And you can also see that I have black lines. Basically, the lines going in whatever direction that they're going, those are the same length. So the pink lines that go across, those are all 2 meters. The orange lines that go up and down, those are all 14 meters. And the black lines that go diagonal, those are all 10 meters. So what we're going to do is we're going to take this information and we're going to figure out the area of each of these individual rectangles. So with this tall, skinny rectangle, orange is 14, so it's going to be 14 times, the pink is 2, 2. 14 times 2 is going to be 28. So this is going to be 28. Over here, this is also 14 times 2, so that will also be 28. With this rectangle, I have a black line and an orange line. The black line is 10, the orange line is 14. So the area of this is going to be 10 times 14. And 10 times 14 is 140. So this area is going to be 140. Same thing over here, it's black line, orange line, black line, orange line. It's going to be A equals 10 times 14. A equals 140. Now with this one, I flick the black line and the pink line. So that's going to be black line and pink line. It's going to be 10 times 2 will be 20. And the same thing over here. Now that I've found the area of each of these rectangles, what I want to do is I want to add up all of these areas to find the surface area of the entire shape. So I have 2 28s, I have 2 140s, and I have 2 20s. Let's figure out what each of these added up are. I have 28 plus 28, which is 56. I have 140 plus 140, which is 280. And I have 20 plus 20, which is 40. When I add each one of these up, I'm going to get 376. So the surface area of this entire shape is 376 meters squared. Now what you're going to do is you're going to take a look at both of these methods and figure out which method you think works better for you to explore tomorrow.